Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapience education. So today I am going to discuss about the chapter electric charges and field for the class 12 board, which is very important. So this is part one of the video. I will go chapter wise as well as part by part. So for uh, for stay updated regular visit, I will all give you regular videos at time by time. So let us discuss about chapter this few topics. So what is electrostatics? So see here, uh, electrostatics. Before that, we need to understand statics means what. Static means rest. Statics means rest. So when a charge is at a rest, so the study of a charge is at a rest, right? Study of charge at rest, right? Study of a charges at a rest is known as electrostatics. So we will, whatever we will discuss in electrostatics, so all about charges at a rest. Okay, so electric charge, it is a property associated with the matter due to which it produces and experiences an electrical and magnetic effect. This is a property. Electric charge, what is electric charge? It is the property associated with the matter due to which it produces and experiences an electrical and magnetic effect. The excess or a deficiency of electron in a body gives you the concept of a charge. Why it happens? See, let us consider. Let us consider there is a body, body, or there is an atom in which there is a number of neutrons as well as proton, and in outside you know that there is an electron. Okay, so what will happen if electron? If I will remove the electron, so what will happen? If I will remove the electron, so what will happen? So the let us consider it is a neutral charge, neutral atom. So when neutral atom, so number of proton is equal to 10, and number of electron is equal to 10. Okay, so this is plus charge and this is minus charge. So overall it will give you as a neutral, right? But if you remove, after removal of electron, what will happen? After removal of electron, what will happen? After removal of electrons, so let us consider plus p charge is equal to 10 and minus electron is equal to minus 9. So net charge will be plus 1. Okay. So when you remove electron from an atom, so it will become positive charge. It will become positive charge. I hope you have understood. Now let us suppose if I will add on, so what will happen if I will add an extra electron? So if you add on extra electron, so let us consider this is plus proton will remain fixed, so this will be 10, and if you add an extra electron, so minus charge will be minus 11. So overall this will be minus 1. Okay, so there is an imposement of the negative charge when you give an extra electron to an atom. So gain of electron gain of electron means it will create negative charge, and loss of electron will create a positive charge, right? And the proton and neutron will remain in a nucleus part, right? So I hope you have understood this concept. So the excess or a deficiency of electron in a body gives the concept of a charge. Either it is a positive charge or either it is a negative charge. Now basically the SI unit of the charge is Coulomb or ampere second. So basically we will use Coulomb. See, this is the SI unit of the charge. Okay. Now let us go forward for the next slide. So charge is your proton and electron. Now try to understand, unlike charge attract each other. See, this is a positive charge and this is negative charge, so there will be an attraction, right? But when there will be positive and positive, so what will happen? Repulsion will happen. What will happen? Repulsion will happen. Either you can also take here negative charge and negative charge. If any body having a negative charge, so there will be a repulsion. So what we have found, like charge, it will repel each other, but unlike charge, it will attract each other. I hope you have understood this, right? Okay. Now go for how charge is being created. See here, normally atoms are electrically neutral as number of proton will always equal to number of electron. So the total charge will remain 0. Why? Because number of proton is, for example, 15. So number of electron will be also 15. So when you add on these both charge, so it will become 0 charge. That's why normal atoms are electrically neutral, right? Now when any atom lose electron, it becomes positive charge. And when any atoms gains an electron, it become a negative charge. That's why we have already discussed. Now, how to find the polarity of the charges? So this is very important. So gold leaf electroscope is there, and you can find it with the polarity of charge. Let us understand that we have already positive charge. We have already a positive charge. Let us see from the figure. From the figure, let us see here. Gold leaf has a positive charge, or gold leaf has a negative charge. Let us consider. This is the negative charge, or there is a positive charge. Anything you can consider. Let us consider only positive charge, because here they are using positive charge. Got it? Okay. See here. Before that, we will need to understand that this is an atom, collection of atom having positive and negative charge. Now what will happen if a rod with the negative charge, will get touched? So what will happen? As we know that negative charge will attract positive, so positive, whatever there will be a positive charge, it will come up, and it means that there will be a movement of negative charge below this, and this is how there will be a repulsion. There will be a repulsion, right? There will be a repulsion. Okay. So there is a repulsion in this gold leaf. Why? Because there is in both the side there is a negative charge. Got it? Now the task is that if you want to find a if you want to find a if you want to find a polarity of a charge, either it is positive or negative, so we can put here known charge. Known charge. Let us suppose known charge is negative. So due to this, what will happen? Repulsion is already there. Now if you put a unknown charge, unknown charge, if there is an unknown charge, and if you touch this unknown charge, so what will happen? It will go. If extra repulsion will happen, it means that there is a negative charge. Why? Because it is already negative here, and if you put extra negative, so there will be more repulsion. But if there is an attraction, if it is, see here, earlier it has a negative charge. Due to this, there is a divergence, and when you put an unknown charge and there is an attraction between the gold leaf, so it means that it has been definitely a positive charge. So in this way we can find the polarity of any charge. Now here, what is conductor? Any object with conductor charges is known as conductor. When a charge is at rest, see here, when a charge is at rest, so what will happen? There will be no electricity, because electric current, you know the basic formula. Have you read in the class 10 that electric current is the flow of charge? Flow of charge, right? Now, if there is a conductor, and in this conductor there is a static charge, positive charge, so what it will do? It will produce an electric field, E. Okay. Now, if there is charge is moving, V is not equal to 0 means it is in motion. It may be motion. So consider a velocity is constant. So what will it will produce? Electricity and magnetic field. So try to understand again and again. If charge is at rest, so it only produces an electric field. But when charge is in motion, so let us consider velocity is constant. It is moving with the constant velocity. So it will produce electric field and magnetic field. Magnetic field means what? It will create a magnetic effect outside its conductor. Okay. Now let us, when a charge is moving with the variable is velocity. For example, a charge is moving with, for a second it is 10 meter per second. After a while it will become 11 meter per second, after a while it will become 12 meter per second. It is increasing, or it may happen that there is a 10 meter per second, there is a 9 meter per second, so it may be increase or may decrease, we don't know. But it should, velocity should decrease or increase or a variable. So if it happens, then what will happen? As you know that if velocity is constant, so electricity will be produced here also, electric field will be produced. Now, one thing more you need to know, that it will also produce a magnetic field, but earlier case also it has produced a magnetic field, magnetic effect. Now, the which it will extra produce is the wave. Okay, wave, you know that it will consist of electric field and magnetic field. So you know that light is a form of a wave only. So wave means what? There is an extra there is an, see, there is, suppose it is your electric field, and this will create a magnetic field. So electric field create a magnetic field, this magnetic field will create a electric field, and this electric field again create a magnetic field. So this magnetic field again create a electric field, and this will create a magnetic field. So this is what, all electric field and magnetic field energy gets transferred from E to F, E to magnetic field, and in this way this way move forward. That's why, that's why electric wave does not require, does not require any, does not require any medium, right? So electric field as well as magnetic field is there, and due to the variable velocity it produces a wave, and this wave does not require any medium to get transfer. I hope you have understood this. Now let us go for distribution of charges in a different shapes. So charges of uniform distribution, see here, it is symmetrical circles. So there is a uniform distribution, means what? Charge density remain constant. In this what happens? Charge density, in this charge density will remain constant, will remain constant. Now if there is a non-uniform object, so charge density will change. So see here, if radius of the curvature is very large, so density is less, charge distribution is less. But if radius of density, radius of the curvature is small, r is small, so the density will be high. I hope you have understood this. So you should always remember density is directly inversely proportional to the radius of the curvature of the shape. So hence we can say that it is not like that always you will get an uniform distribution of a charge. You may get non-uniform distribution of charge if an object is not symmetric, if an object is irregular. So it depends upon the situation. It depends upon the shape of the conductor. Now, very important point charge. When overall charges is considered at a point is called a point charge. For example, many charges are there, but I will consider a whole charge as a single entity, and this is known as point charge. Now, we will go for a material. So how many types of materials are there? So there are three types of material: conductor, insulator, and semiconductor, as per the movement or as per the flow of the charges or the flow of a charge in the material. So there are three different type of material where the flow of charges happens. Now first of the material is conductor. In conductor, what happens? In conductor, what happens? Current will flow in this conductor, and insulator current will not flow, and semiconductor depends upon the temperature. Okay, so how this happens? See, conductor. So basically what happens in conductor, there is a free charges. Okay, but in insulation there is no free charge. And in semiconductor, what happen if electrons gains the energy, electron gains energy, it will start moving. It will start moving. It means that you have seen that silicon is the best example. In silicon, what happens if temperature increases? So what will happen? There will be a flow of charges. So there are three types of material: conductor, insulator, and semiconductor. In insulator, there is no free charge, so there is no electric flow. But in conductor, there is a free charges. But in semiconductor, there is a charges, but it does not have a sufficient amount of energy so that it will start moving. So it for movement of the electron across any potential difference, we should also give a high temperature. So the solar panel is the best example. In solar panel, silicon doping is done. So I will discuss in the later also in a more elaborative way. So there is a doping of a silicon material with the tri-doping or tetra-doping. So what happens? Uh, there is a movement of electron when sun rays fall. So electron gains energy, and when it gains energy, so it start moving across this. So when it starts moving, so what will happen? Movement of electron makes a current flow. So it creates a current. So this is the sole example of a solar panel. Okay. So I hope you have understood this as a point charge. Now let us move forward for this properties of electric charge. So what are the properties of the electric charge? We should discuss these things. So first and the foremost property is additive of the charges. See here, additive means what? Generally, as per the algebra only we can add here. So let us consider there is a minus 2 Coulomb charge and plus 4 Coulomb charge and 5 Coulomb charge. So net charge will be minus 2 plus 4 plus 5. So this will be 7 Coulomb. So it will be added algebraically. Charge is a scalar without changing any of the symbol. Okay. So I hope you have understood the additive nature of the charges. Now let us go for the conservation of the charges. So total charge of an isolated system will remain conserved. It will neither created nor be destroyed. You can't create a charge. It can neither be created nor be destroyed. It can only be transferred from one object to another. For example, there is a atom having a zero charge, but there is an atom having a minus 4 coulomb of a charge. So minus 4 coulomb means what? Or minus 4 charges is there. So let us consider if it transfer an electron, so it will become what? It will become minus charge and it will become 0. So this is in this way there is a transfer happens. Okay. Next is quantization of the charge. Yes, very important. Charge is an integral multiple of the electron. Yes, that's a very important thing. Let us consider you can't tell that there are 4.5 child in classroom. You can't tell, right? So it means that child is an integral form. You can either count one, two, three. You cannot tell that there are 4.5 student with there is 5.5 student or 5.5 person. You can't take this. So charge similarly, what happens? Charge also remain in the form of a quantization of electron. So see here, it is charge will always be a multiple of a Ne. Okay. So it will come in the form of the packet of the electrons. So either charge will have 1 electron, 5 electron, 8 electron. But you can't find 8.5 electron. This is totally wrong because you can't divide electron. I hope you have understood. So this quantization of a charges, this signify this. Okay. So I hope you have understood this. Now, for invariance of a charges. If electric charges is at a rest or in a motion, it does not affect the charges. It will remain same. So either it is in motion, either it is in rest. So it will not change the charge. So charge will remain charge either it is negative or positive. So this is the fourth point. Okay. Okay. And charging can be done. See here, charging can be also done, but it is, I think, it is not in the syllabus. So charging method. So let us discuss about the Coulomb's law. So first of all, we need to understand what is Coulomb's law. See, Coulomb's law. It has been perhaps the scientist who has given this law. As per this law, basically, before reading the statement, you need to understand that there is a charge Q1 and Q2. It may be positive, it may be negative. It may happen that it is negative, it may be positive. It may happen that it will both will be positive, it may happen that both will be negative. So what will happen? It will experiences a repulsion force or attraction force. So the force of interaction between any 2 point charges is directly proportional to the product of a charge. It means that the more quantity of a charge will be there, so the more force will be there, and inversely proportional to the square of the distance between them. If you increase the distance, so what will finally happen? Force will decrease. But try to understand here, force is directly proportional to F is directly proportional to the product of the charge. If you increase either of the charge, so what will happen? The force will also increase. But at the same time, force is inversely proportional to the square of the distance. It means that if you have double the distance, so force will decrease by 4 times. So this is what you have understood right now. So Coulomb has told that force is directly proportional to product of a charges and inversely proportional to the square of the distance. Now, when we remove the proportionality constant, so we are going to get as a k as a constant, and it is known as electrostatic constant. It is known as electrostatic constant k. K sometimes also have a values. Sometimes k can be written as 1 by 4 pi epsilon naught. So let us discuss more about the case. So I hope you have understood now what is Coulomb's law. It gives the force value of the force between the two charges and how it behave when a charge is increased, how it behave when the distance between these two charges will increase or decrease. So this is given by the Coulomb's law. I hope you have understood this. Okay. Now let us go for a next slide. Uh, Now we got the quantity electrostatic constant K and depends upon. So these depend upon the nature of the medium is separating the charges and the system of the units. So system of unit K is equal to 1 by 4 phi epsilon naught, and the value of this is 9 into 10 to the power 9 Newton square per Coulomb square. So if you want to find the unit, so you can also use this concept F is equal to Q1 Q2 by R square into K. So K is equal to F R square by Q square. So F is a unit Newton, R square is a unit meter square, and divided by charge square is Coulomb square. So in this way, Newton meter square per Coulomb square. So if you want to, if you have forgot, or if anyhow, if you unable to find the unit of the K, so you find this way, right? Now, the most important thing, what is E naught? E naught is the electrical permittivity of the free space. Okay, and E naught is equal has the value 8.85 into 10 to the power minus 12 Coulomb square per Newton meter square. I hope you have understood this. Now we know that already you know that we have studied in class 11 a vector. So most of the things we will discuss in the vector form as well. Okay, whatever we are finding, so we should also find in the vector form. So let us go. As you know that force is a vector quantity. So how, which direction the force is being applied? So we need to understand here. So step by step we will go here. Okay. So try to understand here. This is a x-axis, y-axis, and this is their x-axis, and there is the two charges q1 and there is another charge q2. So we know that the position of the charge at a q1 can be written as r1, and the position of the q2 charge is can be written as r2 from the initial position. So if we take this reference frame of reference, I hope you have studied in the vector chapter in the class 11 already. Now can you tell the distance between this? So the distance between this will be this will be when you go from 1 to 2, so R1 to 2. And when you go from 2 to 1, so this will be R to 1. So this we have already done, right? Now, if you want to find the force on a charge Q1, F12 means force on a charge Q1. Force on charge Q1, force on a charge Q1 due to Q2, due to Q2. If you want to find a force on a charge Q1 due to Q2, so how you will do this? So this will be F12. So the product force will be what? Product of K into Q1, Q2. But what distance are there? So magnitude of a R12 or 21. See here, magnitudes are same. So R21, if you talk about R21 and if you talk about R12, so the magnitude of both the distance are same, but the directions are different. So which direction we should take here? So the force on a charge 1, that is F12, is applied by this Q2. So this force direction will be this time. So the distance will be given in this direction. So we can take it as a R21 into R21 whole square into R21 cap. So I hope you have understood this. Now, if you want to find the force on a charge Q2, so if you want to find the force on a charge Q2 due to Q1, so the force will be in this direction. So the direction of the distance will be also R1 to 2. So force on a charge 2 1 is equal to K Q1 Q2 by R1 2 whole square into R1 2 ka cap. So now let us understand that whenever you take suffix as a 1 2, so the distance suffix will be 2 1. So basically it is the method to memorize it. Now you should always remember that R12 is equal to vector in negative of the vector R21. Now you will tell me that how you have find R12 and R21. So you know that this is 3 triangle law of vector addition. Use this. So when you will use this, so you will get this distance. I hope you have understood this. Coulomb's law in a vector form. So this is the basically fundamental fact about Coulomb's law in the vector form. Okay. So R12 can be written as R12 by divided by magnitude this. R21 cap is equal to R21 by magnitude of the R21. So it is most familiar things you have already studied in the vector chapter. Okay. Now we will also discuss about the force between multiple charge, as we have already discussed about the force between two charge, but it is in practical most of the things happens in multiple times. See here, there are lots of charges. Okay, let us consider 1, 2, n charge, q3 charge, q2 charge, and there is q1 charge. I want to know that the force applied on the charge q1 will be what. So see here, if you literally if you want to see this as a q1 charge, so first of all I will go due to q2, so the force acting in this direction, this will be f12. Force due to q3 will be this will in this direction. Force due to nth charge will be f1n. So all these three forces are acting in a different directions, but since you know that the force are vector quantity, so you need to add this vectorially. So this is f12, this is f13, and this is f1n. So we can this add on vectorially, so we may get all these three as a resultant form, so fr. Okay, so in this way we can find out the force due to multiple charge. Now we will talk about the basic things that always you don't need to do these things. Okay, so that so you should always take like this: force on a charge q1 due to n charge is equal to force on charge due to charge 2 is equal to k q1 q2, this one. Force due to charge 3 on a 1 is equal to k q1 q3 by r31 whole square, as we have already done previously. Now force due to nth charge is equal to k q1 q2 n by rn1 whole square into r1 n1 cap. Now we will add all this force vectorially. If you will add this force vectorially, then you will get the force on a charge 1, force on a charge 1. So basically force on a charge 1 can be written as F12, F13, F1n. So you can also put here the values. So you have already we have already done this. So how you will find the values? See, let us consider F1. So F1 will be equal to F12. So F12 is what? K, K Q1 Q2 by R21 magnitude into R21 cap plus K Q1 Q3 by R1 R23. It is not R23, it is your R31 R31 magnitude of R31 into R31 cap plus K into Q1 into Qn by Rn1 magnitude into Rn N1 cap. Now what are common? So common case is divided by K, there is nothing else, and Q1 into Q2 by R21 vector you can write. You can use this as a vector form, so no need to write here also. So we can also write Q3 by R31 plus Qn by Rn1 vector. So in this way we can find the vector addition or find the net force due to multiple charge. Net force due to multiple charge. So I hope you have understood this. Okay. Now one more important thing is your dielectric constant. What is dielectric constant? Relative electrical permittivity. How much permit you are giving. Okay. So let us consider ER as a relative electrical permittivity. The force we have already done, that force is equal to 1 by 4 pi epsilon Q1 Q2 by R square. But what happens when it is in air or vacuum? The permittivity is E naught. But as soon as any other medium comes, so the relative permittivity become impermittivity become E medium into Q1 Q2 by R square. Now if we divide this equation, so what we are getting? We are getting relative Em by E naught. So Em by E naught is known as relative permittivity. It means that the permittivity compared with the air or vacuum. So we can also write like this, that permittivity of medium compared with permittivity at vacuum or air. So whenever we will compare any permittivity in a medium with the air, so we will get as a relative permittivity. So relative permittivity of the electrical permittivity is known as dielectric constant. So I hope you have understood this. Now, one more important thing we can see here, one revision is that force on a Q1 due to Q2. So force on a Q1 due to Q2 is equal to Fk Q1 Q2 by R21. Why R2? I'm telling, because force is in this direction, so the R will go from this to this direction. So always remember here, this won't work, right? This won't work. Always use this. Always use this concept. See here, reversing concept. Always use this reversing concept. What reversing concept? See here, if there is a 1 2, so here you have to write 2 1. If there is 1 3, so you have to write 3 1. And if there is 1 n, so you have to write here 1 n 1. Okay, so always just reverse so that you can get the proper direction. Okay, so I hope you have understood. Hmm? um, See, this is not in the syllabus, but still I will talk more things about electricity and all in the next part of the video. So till now, it's okay. I hope you have understood this, and I hope you have enjoyed the session. I want to inform you that there will be a regular class as well as there will be a live session for the practice problem. So regular, I will feed up the theory part If you want to know more about, please inquire us. Please write in comment section below given. Okay. Thank you for attending my class.